In this video, I'm going to introduce you to vector functions. So this is an example of your vector function. So we've seen this in the past. Without this would be your standard parametric equations. We've seen this in the past. So you've got your x-axis, your y-axis. This thing here tells you the location in the x direction. Let's say in the x direction is somewhere around here. In the y direction, it's somewhere here. So this thing here tells you the location in the y plane, but now we need to extend it into 3D. So now this will then tell us the height in 3D space. So this thing here tells you the location. Now with vector functions, you've got to picture this as this. This I hat here, in your mind, picture it as a unit-based vector. So think of this I hat here as length of length 1. So this I hat here is 1, 0, 0, and then this j hat here is of length 1 in the y direction. So this j hat here is really 0, 1, 0, and then this is the height. This is the height here. So think of this as having a length of 1. So this would be 0, 0, 1, and then you've got a function. You've got a function that governs the movement in the x direction or in the I direction. So this function here tells you how far you have to move. So for example, let's say the particle is moving along this path and currently is at this point here, P. So you've got some sort of function that tells you how far you should move in the I direction. So let's say you've got a function that gives you, let's say, the answer of 1. So this thing here is 1, so 1i. So you move 1 across in the I direction. And then let's say you've got a function that gives you, I don't know, let's say 3. This thing here is 3. 3 in the j direction. So you've got to move 3 across in the j direction. And then let's say you've got some sort of function that gives you a 5. So you move 5 up in the k direction. So 5 up. So that would then take you to here. So with vectors, you're looking at the movement from one place to another, from the origin to this place. So when you think in terms of vectors, a vector function is really the movement from the origin O to P. So it's a movement from here. It's a movement from here to here. This thing here just tells you the location, the precise location in 3D space. So this is your x coordinate, this is your y coordinate, and this is your z coordinate. It tells you the location. This thing here tells you the movement, how you would get from the origin to here. So you have to move in the I direction, you have to move in the j direction, and then you've got to move in the k direction. It's actually the movement. This is the movement. This is just a location. So we are dealing with the movement, the journey from one place to another. Okay, so as the particle is moving along here, you've got to think of it as being, when you work with vector functions, you've got to think of it as the movement from here to here. So it's really the vector. Remember, vectors is the movement from one place to another. This is the location. So you actually move. So when given this, you've got to think of it as this. So let's say at one time is here, another time is here. So in your mind, you've got to think of it as this. It's the actual move. This thing here will give you a vector, and that vector is from here, from the origin to here. So let's say the particle is here. This thing here will then give you a vector from the origin to here. So you've got to picture this arrow in your mind. So let's say the particle is currently here at the moment. So you've got to picture this vector. So to describe this journey of this particle is actually describing all the vectors pointing like this. Hang on, it's pointing along the path. So it describes a journey in terms of vectors. So for example, oh, by the way, this is your scalar function. So this is your scalar function. This is a scalar function. This is a scalar function. The whole thing here is your vector function. Okay. So hang on. Let me give you an example. So without the k direction, let's ignore this. you know that this is going to be a circle. This is going to be a circle. But then when you introduce the k component, you're adding a height to it. So after 1 second, it will be a height of 1. After 2 seconds, it will be a height of 2. So without this, you've got a particle moving like this on a flat surface in circles. And then if you introduce this k here, you've got a height. So after 1 second, it would be at a height of 1 here. And then after 2 seconds, it will have a height of 2. So it will be at a height of 2 like this. So after another second, it will be a height of 3 and so on. So what you've got here is a helix. You're describing the path along here, and don't forget what you've been given here are vectors. So you've got to think of it as an arrow pointing from the origin to here. So let's say the particle is here. You've got to think of it as from the origin to here. So let's say the particle is moving and it's right here. So you've got to think of it as a vector from the origin to here. So you've got arrows pointing along the path. So you've got to think of it in terms of arrows pointing at it. So now you can adjust this. Let's say you stick a 3 in here. So normally you've got a circle of radius 1, but because of this 3 here, you now have it's like an ellipse. So you can alter this. So it's moving like this. Hang on, it's moving like this. Hang on. So without this bit here, it's going to move like this, like an ellipse. But then when you start to add the k component, it's going to give you an ellipse where the height climbs each time. So it's like this, and then like this, and then like this. You're going to have like a helix, but in an elliptic shape. Or you can change this thing here. Let's say you can change this thing here. Let's put 3 in here. So after 1 second, it will be at a height of 3. So normally this thing here would be a circle of radius 1. But because you insert a 3 in here, after 1 second, it will have a height of 3. So let's say this is 1, 2, 3. So after 1 second, it would have done. Hang on, let me think. It would have done something like this. Hang on. After 1 second, it would be something like this. It would climb really fast. Or you could change. You could insert let's say a 4 in here. So it's going to have 4 cycles in one second. My point. Let's say this is 1 here. So it's going to have 1, 2, 3, 4. It's going to have four cycles in 1 second. But the point is that if you insert a number in here, but keep this the same, then you're just going to have more cycles in 1 second. 4 cycles in 1 second, and then another 4 cycles in 1 second. And the point is you can alter this by changing, I don't know, 7 here. So that would increase the radius of your helix and so on. Okay.